November 2021, paper 1, variant 2. Hmm. Which list places units of length in increasing order of magnitude? Increasing order of magnitude. Yes, it is B. Millimeter is the smallest, and then centimeters, and then meters. The smallest, okay, increasing order of magnitude. Ascending order, if you might say. Which graph represents which graph represents an object that is moving at a constant speed? Constant speed would be, hmm, let's check them out. A, he's at rest. Okay. B, initially was at rest and then he was increasing the speed. Increasing speed, no. C, at rest and then decreasing speed, okay. Which is wrong. Yes, it is D. Yes, thank you. It is D. To be very honest, this graph should be another type of graph, but it's okay. Distance time graph. When the slope is constant, you have a constant speed. Which statement about the equation is correct? Which statement is correct? G is a force. M is a force. W is a force. Weight is a force. G and M are not forces. Yes, G and M are not forces. Okay. Shab, when you say G is the gravitational force, that's wrong. G is not the gravitational force. G is what? G is the gravitational acceleration. Okay. You need to be very specific when talking about the G. G is the gravitation acceleration. W is the weight, which is a force. Which substance has the lowest density? Density equals mass over volume. For each of these, we need to calculate the mass of volume 1.2 over 1, 1.5 over 1, 1.8 over 2, and 2.0 over 2. This would result in C, which is 0.8, 0.9. Okay, we have two loads, X and Y, and we can move, okay? We can move these loads. We can move these loads. Which graph shows how the moment produced by load Y varies as the perpendicular distance from the pivot changes? Which graph shows how the moment produced by Y, how the moment produced by Y varies as the perpendicular distance from the pivot changes? When you increase the distance, yes, thank you. When you increase the distance D, when you increase the distance D, what happens to the moment? The moment increases. So definitely C and D are wrong. Why? Because as the distance increases, the moment does not decrease. The moment does not decrease. Should it be curving? No, it's not a curve. It is a directly proportional relationship. As the distance increases, okay, as the distance increases, what happens to the moment? The moment increases as well. Hmm. A spacecraft is traveling in space with no resultant force and no resultant moment. Which statement about the spacecraft is correct? When it is traveling with no resultant force and no resultant moment, what happens? Uh, It's in equilibrium. It has to be in equilibrium. Hmm. These are the conditions. And it's, yes, it is moving at a constant speed. It should be moving at a constant speed. This is correct. But it's not in the answers. Sadly, it's not in the answers. Hmm. Soon carries out an investigation by pulling four different boxes across the floor. Which box is the most work done? On which box is the most work done? Someone's saying D, 20 times 4 is 80. Yes, 80 newtons. 80, I'm sorry, 80 joules. Okay. If you calculate any other, for example, on box A, it would be 20, 20, 30. So it's only 80. Yes, it is D. Electrical energy may be obtained from nuclear fission. Which order is the energy transfer in this process? Huh. Nuclear fuel, what happens to nuclear fuel? It cannot go on to the generator. Okay, it reacts and then the generator, then turbine. No, you need to rotate the turbine and then the turbine rotates the generator. Yes. A stone falls. Which row gives the energy changes as it falls from above? What happens? The gravitational potential energy. As it's falling, what happens to the height? The height decreases, and the kinetic energy hmm, increases as it falls from above. The height decreases, the gravitational potential energy decreases, but the kinetic energy increases. Hmm, Okay. Which motor requires the greatest power? Okay. The time taken is the same for all of these motors. The time taken is the same. Which motor requires the greatest power? The greatest power, I guess, would require the greatest work done. Hmm. Which of them would be the greatest work done? Yes. Okay, it is B. Just 10 times 2 is 20. I'm sorry, it's not B. Okay, this is 20, this is 15. Okay, this is 10, and this is 6. Yes, it is A. Okay, so yeah, B is wrong. Good. This question is cancelled. Okay, barometers have been removed from the syllabus. The liquid is evaporating, it's not boiling. Which statement about the liquid is correct at any instant? Uh, Work done is force times distance. Yes, work done is the force times the distance. He needs the greatest work done. Okay, to find the greatest power over the same amount of time, you need the greatest work done. I know this is mass. What I did was mass times distance. Again, it is directly proportional. So basically, mass to find the weight or to find the force, you need to multiply times 9.8. Again, it would give you the same answer. You're not actually required to calculate the work done. You just need to understand that the mass is directly proportional to the weight. So when you increase the mass and the distance, the total work done will increase. Okay. Okay. Again, a liquid is evaporating, it's not boiling. Which statement is correct? Any molecule can, no, not any molecule can escape. Only molecules with enough energy can escape. Only from the surface. Cannot escape from any part. Yes, it is C. Temperature of the gas in a sealed container of constant volume decreases. Sealed container. Okay? Constant volume decreases from 20 to 12. Which row? What happens to the pressure? And what happens to the average speed? Okay. I guess the average speed would be easy. Why? Because when you're checking the temperature, what happens to kinetic energy? The kinetic energy decreases as the temperature. hmm, When temperature decreases, the kinetic energy decreases. So the average speed would decrease. What about the pressure? The pressure would also decrease. Why? Because they hit the walls with less force. Okay, they're now moving slowly. Okay, when they move more slowly, they hit the walls with less force, and the pressure eventually decreases. Yes. A long, thin bar of copper is heated. What happens to the bar? What happens to the bar? Well, it's quite easy. When you heat anything up, what happens? Thermal expansion. Hmm, Thermal expansion. So it basically becomes longer. A teacher makes the statement, object P. Okay, oh, this is cancelled. Thermal capacity. This is cancelled. Well, question 16. Diagram shows a pan used for cooking food. The base of the pan and the handle of the pan. The base of the pan and the handle of the pan. The base should be made of a good conductor, definitely. And the handle should be made of a poor conductor so that you wouldn't. Okay, yes, okay, so that you can hold it. Diagram 1 and diagram 2. What's diagram 1 and what is diagram 2? Hmm. Yes, quite easy. A 2 is definitely diffraction. Yes, 2 is definitely diffraction, and 1 is reflection. Hit the wall and then moved with the same angle. Which row is not correct for a wave? Which row is not correct for a wave? The amplitude. The usual unit is meters. Yes. Frequency, hertz. Yes. Wavelength, lambda. No, it's not lambda. It's actually meters. Lambda is the symbol. Lambda is the symbol. There's a huge difference between the symbol and the unit. Symbol is just whatever represents a wavelength, but the unit, whenever I tell you measure the wavelength, you need to measure the wavelength and say the unit of the wavelength is usually in meters. A thin converging lens causes parallel rays to converge to a single point known as the principal focus. Which statement explains this? Why do they converge to this principal focus? Yes, the light doesn't diffract, it doesn't disperse, it doesn't reflect, it only, or in this case, it refracts, it bends, okay? It refracts and bends towards the focal point or the principal focus. Hmm. Any questions? This is quite easy. Which row gives the angle of incidence, and is this total internal reflection or not? The angle of incidence has to be between the ray and the normal line, so it has to be Q. Okay, Q. Is this total internal reflection? Definitely not. Why is it definitely not total internal reflection? Because you cannot totally internally reflect when moving from air to glass. Never. It will never happen no matter what. Okay? There's no condition. Never. Okay? It can never happen while moving from air to glass. It only can happen when moving from glass to air or from water to air, for example. Okay? Has to be from the more dense medium to the less dense medium. A total internal reflection. The letter F is reflected in the mirror. How can I see it in the mirror? This is a lateral. This should be laterally inverted. No, it should be laterally inverted. So it would be B. Yes, laterally inverted. Quite easy. Visible light, X-rays, and microwaves are all components of the electromagnetic spectrum. Which statement about the waves is correct? In a vacuum, microwaves travel faster. Nope. In a vacuum, microwaves travel at the same speed. Yes, they do travel at the same speed. And visible light shorter, has a shorter wavelength than microwaves. Rami looks great. Okay, visible light has a shorter wavelength than the microwaves. Okay, but in this question, he's saying that in a vacuum, microwaves travel at the same speed and have short. No, it's the other way around. It's the visible light that has a shorter wavelength. So this is wrong. X-rays travel faster. Nope. X-rays travel at the same speed and have a shorter wavelength. Yes, X-rays have a shorter wavelength than the light waves. Which radiation has a higher frequency than red light? Higher frequency than red light. Hmm. What do you think? Higher frequency, Rami, as I move this way, the frequency increases. So it would be ultraviolet. Red light is part of the visible light. So whatever is on the right-hand side would have a greater frequency than red light. Actually, if he had said any of the other colors, okay, and any of the other colors, for example, orange, yellow, green, whatever, all of them would have had greater frequencies than red light. What is ultrasound? What is ultrasound? Sound waves that are so loud, too high pitched, too low pitched, too quiet for humans to hear. It's not about the loudness of the sound. It's not about the loudness of the sound. It's about the pitch. Okay. Whenever the frequency increases, yes, whenever the frequency increases above what? Above 20,000 hertz. Any frequency, any sound frequency above 20,000 hertz is called an ultrasound. As humans, we cannot hear this ultrasound. Okay. Okay, good. Which material is magnetic? Um, only iron. Which circuit symbol represents a component used to measure the electric current? Very easy. Four wires made of the same metal have different lengths and different diameters. Which wire has the lowest? Huh, lowest resistance. How can I decrease the resistance? Again, decreasing the resistance. What should I do to the length? You have to decrease the length. You have to shorten the length. What should I do to the diameter? You have to increase the diameter. Yes. Why? Because the diameter is inversely proportional. Whenever you have a larger diameter, what happens to the resistance? The resistance decreases. Okay? Hmm. This is a really interesting question. Voltmeter connected across the 1 ohm resistor by connecting P to X. Okay? The reading on the voltmeter is now, okay, if it is at point X, the voltmeter would have a reading of 6 volts. Okay, so the potential difference, the voltage of this 1 ohm resistor is 6 volts. Okay, quite easy. What you should know is what? You need to know that the resistance and the potential difference are directly proportional. The resistance and the voltage, for example, or the potential difference are what are directly proportional. So when you increase the resistance, the voltage increases. If the resistance was 1 ohms and the voltage was 6 ohms, so the resistance is now 2 ohms. Okay, you increase the resistance and the voltage of this resistor alone, again, the voltage of the second resistor alone is what is 12 volts. The voltage of the second resistor, why? Because you multiplied the resistance by 2, so the voltage or the potential difference will be multiplied by 2. The total voltage, again, wire P is moved to point Y. P is moved now to point Y. So the total resistance would be 6 plus 12. The total resistance would be 6 plus 12, which is 18 volts. Again, you need to understand that the voltage, potential difference, and the resistance are directly proportional. So whenever you increase the resistance, the potential difference or the voltage would increase. Now I increased the resistance, I just multiplied the resistance by 2. So basically the potential difference would be multiplied by 2. But I need the total voltage of them both. Okay, I need the total potential difference of them both, which would be 18 volts. Okay. Mm. Which device is used to measure the flow of charge in an electrical circuit? Flow of charge. Flow of charge is what is the current, which is an ammeter. Which circuit contains a fuse? Quite easy. The only circuit containing a fuse is C. A student designs a circuit to turn on a fan when the temperature, huh, when the temperature increases. Which of these components has to do with the temperature, with the heat? Yes, definitely D, which is a thermistor. Okay, thermistor. C is an LDR, a light-dependent resistor. Again, this is a fuse, and the first one is a lamp. Okay, so the only one that has to do with the temperature is a thermistor. Hmm. Two resistors, R1 and R2, are in parallel. Okay, the resistance R1 is greater than the resistor R2. The total resistance would now, if they are in parallel, the total resistance has to be, total resistance, yes, has to be less than either R1 or R2. For example, if R1 was 100 ohms and R2 was 5 ohms, so the total resistance of this combination would be less, okay, than 5. Has to be less than either of the resistors. Actually, to be more specific, it has to be less than the least resistor. Okay? Must be less than. Are you required to calculate the total resistance? No, you're not required to calculate the total resistance. You just need to understand that the total resistance would be less than the least resistor. The diagram shows a motor connected to an AC supply. Which device needs to be connected between points X and Y to prevent the wires from overheating? Prevent the wires from overheating. Huh. Yes, it is a fuse again. It is a fuse. What does the fuse do? It protects the wires from overheating whenever the current increases above a certain amount. A hairdresser is using a hairdryer with a plastic casing. He notices that there is no wire attached to the earth pin of the plug. Okay, there is no earth wire. In this case, there is no what? No earth wire. Why is an earth connection not needed? Why is an earth connection not needed? Yes. Okay. Okay, when do we actually use earth connections? We usually use earth connections when there is a metal casing. When there's a metal casing. Because if you touch the metal, you can get electrocuted if there are some electrons or if the metal casing is live or whatever. Okay, if there is a metal casing. But in this case, there's a plastic casing. Plastic does not conduct electricity. The current will not move through the plastic. So it wouldn't be that much of a danger. Okay, the plastic is an insulator. Yes, plastic is an insulator. Okay. Hmm. Four positions of a current carrying wire, current carrying coil in a magnetic field as a DC motor are shown. Okay. In diagrams 2 and 4, the coil is at an angle of 45 degrees to the field lines. Which row is correct? It's a really interesting question. Which row is correct? Turning effect of the forces in positions 1 and 3. 1 and 3. Okay. And 2 and 4. Hmm. Let's choose the easy one. Okay, let's solve the easy part. 2 and 4, they both have the same turning effect. They both would have the same turning effect. Why? Hmm. Why would they both have the same turning effect? Because they're both at the same angle. Okay, they're both at 45 degrees. I guess this is quite obvious and quite easy. Okay, they're both at 45 degrees to the normal position or whatever, to the magnetic field, okay, to the field lines, yes, as he said. Okay. The harder part, not harder, the more tricky, okay, it's a bit trickier. 1 and 3, would they be different or would they be the same? Actually, they would be different. Why? Why would they be different? In 1, the coil is parallel to the magnetic field. In 3, the coil is perpendicular to the magnetic field. Coil 3 would actually, you don't actually need to know this, but coil 3 would experience the greatest, okay? It would experience the greatest turning effect. The greatest turning effect. Why? Because it's perpendicular to the magnetic field. Coil 1 would actually experience zero turning effect. It would not rotate, it would not move at all at this position. Okay. Why? Because it is parallel to the magnetic field. So they are completely different, 1 and 3. 1 and 3 are completely different. 3 is perpendicular. It would experience the greatest turning effect. One is parallel, so it would experience, okay, no turning effect at all. Okay? Okay, good. An electric drill operating from a supply voltage of 240 volts uses a current of 3.5 amperes. What is the rating of the fuse? C, yes, it has to be C. Again, you cannot use the rating in volts. Okay, and it cannot be less than the actual needed current. So it has to be C. Yes, thank you. A very important experiment proved, okay, improved scientists' understanding of the structure of matter. It had some alpha particles. What happened? What happened to these alpha particles? Okay, all of the alpha particles were absorbed by the nuclei. This is definitely wrong. All of the alpha particles were unaffected by the gold atoms. Nope, actually, some of them were affected. Some of the alpha particles were attracted by the neutrons. How can alpha particles be attracted by neutrons? Some of the alpha particles were repelled by the protons. Yes, we know that the alpha is positively charged and the protons definitely are positively charged, so they will repel. Yes, some of the alpha particles were repelled by the protons. A sample contains 0.0016 grams of radioactive material. After 4 hours of the mass, okay, uh, the sample falls to 0.0080 grams. What is the half-life of the isotope? Okay, how can I find the half-life? What is the half-life? What happened? Okay, what happened initially? What did you do? You just divided this by 2. 0.016 divided by 2. It would be 0.0008, which is the same. After how many hours? After 4 hours. So this is the half-life. This is the half-life. Okay, you left it for 4 hours. When you leave it for 4 hours, what happens? It was divided by 2. Okay, this is the half-life. That's it. It's a very simple and straightforward question. It's a very simple question. Hmm, hmm, Okay, sample of radioactive isotope has a mass of 100 grams. The half-life of the radioactive isotope is 6 hours. The half-life is 6 hours. Which graph shows the decay for this isotope? Which graph shows the decay for this isotope? I know that a lot of you would want to choose A. Why? Because, oh, this is a very nice graph. But it's actually wrong. A is wrong. Why? Because he said, okay, he said that the half-life is what? The half-life is 6 hours. After, let's say, half-life, and you divided this by 2, which would be 50. At 50, okay, at 50, the time was less than 1 hour. The time was less than 1 hour. So this is wrong. Okay, this is definitely 100% wrong. Someone's saying B. Okay, let's check B. After 50, this is 50. Okay, it should reach around 6 hours, maybe less than 6 hours or whatever. Is this a graph of a decay, a radioactive isotope? Is this the graph of decay? No, it's not the graph. We all know that the graph of the decay should be something like this. Okay, it's a decreasing, so it cannot be a constant slope. It can never be a constant slope. Okay. The only graph would be C, yes, at 50. Hmm. At 50, it reached around 6 hours. So this is correct graph. It's not perfect. Yes, I know it's not perfect. But again, this is the graph for a um, radioactive decay. Okay, it can never be a constant slope. Okay. Last question. Which statement best describes the background radiation? Background radiation would be, what is the background radiation? Yes. Okay. Yes. It is the radiation from natural sources. natural sources around us do produce some background radiation.